Greetings from Kokilaben Dhirubhai Ambani Hospital and Medical Research Institute, Mumbai, India. Happy Medical Lab Professional Week. I'm Dr. Barnali Das, lead consultant in laboratory medicine in Kokilaben Hospital, and I'm also chair of ADLM, or previously AACC India section, and I was part of IFCC Scientific Division.
This is Smart Cold Lab from Kokilaben Dhirubhai Ambani Hospital and Medical Research Institute, Mumbai, India. So this is the Smart Cold Lab, so where we are putting the samples in the pre-analytical BLIM. This is bulk loader and input module, where the samples are loaded.
That is BLIM. So, and then the samples are vertically aligned in this blue rack. Then sample goes to pre-analytical chamber where there is a camera. There is a blue camera for tube type identifications, and samples are centrifuged here. Cold centrifugation done for all the samples. Then samples are sent to input and output sorter after cold centrifugation. So here there is infrared camera for volume check, level of sample, then QS1 for spin status detection, then quality indices check, then HIL index check, hemolysis, icterus and lipemia check, and then tube decapper is present here. And here also we have out sorter for like online targets of biochemistry and immunoassay and hematology tests, and offline targets like some of the special tests like ELISA, and there are also archiving module. After that, each analytical run, samples are resealed here. So after that, samples are sent to the analyzers for analysis of biochemistry, immunology and hematology tests and other tests. So then after analysis done, samples again come back to output module where for the pending test there are recursive workflow, then rerun, recheck, archiving done. So there is area for unloading if there is a sample error, and also there is loading area for stat sample. So outsorter again there is QS1, we check for final volume, archiving, resealing, rerunning and rechecking of the samples. So resealer or recapper, where the racks can be covered and numbered and stored in the refrigerator. So then sample check and validation, medical and technical validation done in the middleware. So in this total lab automations, sample management, quality management, test management done. So in test management, for example, patient history, trend seen, then reference interval, critical alert, delta check, average of normal. In our smart core lab, consolidation, integration and automation plays very significant roles. So we consolidated our menu, our discipline and workflow, and this improves our speed, efficiency, then improves our quality and also productivity, and it helps us in error reduction. So when we come to assay verification and validations, precision and sigma metrics helps us for our quality improvement project, and also the overhead costs are decreased, and digitalizations like alerts and algorithm, this helps us in increase productivity, also in customer satisfaction and decreasing the overhead cost. So outcomes are simplification of our process, like 74% reduction of sample touches and batching happens. Then around 450 square feet of real estate saving with the consolidation and lean design, and the lab becomes future proof 3 times, and reduction of sample draws 40% reduction in tubes drawn per patient, and turnaround time 60 to 75 minutes. Therefore, the key performance indicator in our Smart Core Lab are speed and efficiency improvement, quality improvement, and then productivity and cost reductions and net promoter score.
I am Dr. Fazlas Kiamuddin from Sri Lanka, at present attached to Kokilaban Dhirubhai Ambani Hospital and Medical Research Institute, Mumbai, India, as part of my post-MD overseas training. I would like to thank IFCC for this opportunity. Located in Mumbai, India, the Kokilaban Dhirubhai Ambani Hospital and Medical Research Institute has a diverse patient population from local, regional, national and international perspectives. Dr. Barnali Das, lead consultant in biochemistry and immunology, a well-known figure in the field of clinical biochemistry and researcher, manages the biochemistry, immunology and toxicology laboratory. Central receiving area is assigned as a separate pool of staff. To avoid delays in transport, samples are received manually as well as through pneumatic tube delivery systems. To minimize the effects of pre-analytical errors, we utilize an efficient barcoding system and maintain strict transport conditions in our laboratory. The Department of Biochemistry and Immunology is equipped with 14 state-of-the-art instruments with backup facility. It covers a wide range of basic, specialized and advanced methodologies to perform tests of general biochemistry, urine and other fluid chemistry, hormone profiles, cardiac biomarkers, hemoglobin A1C, blood gases, therapeutic drug monitoring, extended multiple myeloma panel, antenatal screening, autoimmune and neuroimmune profiles using indirect immunofluorescence analysis, line blotting, and monospecific ELISA for extractable nuclear antigens. As part of the quality control process, internal quality control samples are tested with each batch of specimens. Internal quality control results meet all statistical process control criteria before releasing patient results. We also participate in College of American Pathologists proficiency testing, including accuracy-based assays and calibration verifications and other external quality assurance programs. Our laboratory and the hospital is accredited by national and international bodies like NABL and CAP and NABH and JCI. Indirect immunofluorescence assay needs expertise, practice and knowledge. In our laboratory, indirect immunofluorescence assay covers ANA profiles, autoimmune liver panel, neuroimmune panels with neuroimmune markers related to autoimmune encephalitis and anti-neutrophil antibodies.
We do autoimmune immunofluorescence microscopy and also neuroimmune markers. So if you see, this is autoimmune ANA slides of HIP2010 cells, and we can see the ANA homogeneous pattern. So like this, this is the immunofluorescence testing we do in our lab. So this is the positive and indirect immunofluorescence microscopy. So neuroimmune markers like anti-NMDA receptor, autoimmune encephalitis, then VGKC, LGI1, Caspar2 and many other paraneoplastic syndromes, along with the autoimmune markers like ANE, ANCA, dsDNA, AMA. So we do all those tests. So you must have seen the movie Brain on Fire, the New York Times bestseller. She wrote also, Susanna Kahlan, the cub reporter, who wrote The Brain on Fire, My Month of Madness. So she was a case of autoimmune encephalitis,
And how does it look under microscope? If you see, so if you can see this, so we see this kind of pattern under the microscope, where this is the case of positive anti-NMDA receptor autoimmune encephalitis in CSF. So we do autoimmune testing and neuroimmune testing in our lab.
Laboratory is incorporated in laboratory and hospital information system, and the test validation is done in the middleware. During the technical validation, critical values are informed to the relevant clinical team. The recent success in our laboratory is incorporation of automatic AKI alert. Following technical validation, medical authorization is done by consultant clinical biochemist. This short description may highlight the actions taken by the biochemistry laboratory to minimize the errors and traveling through optimization of the precision and accuracy of the test results end up with better clinical outcome. Thank you.